record it. So now look at this. Whenever you're given something like this, I'm going to draw the universal set, which is x. So first of all, I'll draw my x. This is set x. This is my x. And then I'm going to, they're saying it's starting from 0. And then we have 1 as the smallest number. And then we have 2. And then we have 3. We had 4. Then we had 6. Then 8. And then we had the 10. Then we have been taught to operate these sets. We have been taught to operate this particular set. So to operate this set, we are going to first of all write this guy here. So I'm going to write A using a pen. I'm going to use blue. So I'll say that my A is going to be a set from 1, but 1 is included, so I'll shade it like this. And then I would take it up to 4. I'll take it up to 4. Then I also shade. Okay. And then the same thing, I will write B. B, I will use another pen. Okay. And then I'll take it from 2. They're saying there's an open circle there, but up to 8. Okay, and I'll name this one was A. This is my B. Okay, and then here where there is C, I'm going to put a closed circle like that. I will use another pen. Which pen can I use? This one. And then I'll say this is going to be my closed circle, and then I'll take it up to 6. An open circle there. And then I'm going to say this is going to be my C. And then after that, I'll operate the sets. They're saying B complement. So B complement is this particular set. So this time around you shade. Even there you shade it. Then you take it this end. You also take it this end. Okay. Let me just do this. I'll need this diagram again. I'll need this diagram. Okay, so I will need this diagram. So let me just Okay, okay, I will know, keep drawing the diagram anyway. So let's operate the set. So this is B complement. It is starting from 0 up to some point 2. Then from this is B complement. So also from 8 to 10. So B complement is a set. So 0 was part of the universal up to, okay, from 0 up to 2, the union of from 8 up to 10. That is B complement. And then the second one is A intersection B. A intersection B. The second one is A intersection B. A intersection B is this set. This was set A. So where A and B are intersecting is this set. This set. Okay. So where 2 is and where 4 is. But 4 is part of A and is part of set B. But 2 is part of set A, but it is not part of set B. Okay, so let me just clear that. I don't want to make so much dirty because my board should be neat. So I am going to say that where A and B are intersecting is here. So this is at 2. So I'll say A intersection B is equal to, sorry. It's not supposed to be these brackets. But let me see. 2 is not part of B, but it is part of A. So we'll put these brackets exclusive to simply show that it is. Okay, so we'll say 2, 4 inclusive. And then we can find A intersection B complement. So we have found A intersection B, but let's find A intersection B complement. I'll be very slow. I'll be very slow to do these operations so that we understand. Okay, very slow. Okay, so that's the set there. Then A intersection B complement is the same as A. When we distribute the complement to A to be A complement, then A complement to the intersection becomes the union complement to B, it becomes B complement. Okay, what is A complement? A complement, let me just grab my board properly. So I'm going to clear this. I also clear this. Then A complement is going to be this set. Wait, what are we finding? A complement. So this is going to be our A complement, open circle here in this direction. open circle here in this direction. Okay, so this is going to be my A complement, and this is going to be my A complement. Are we clear enough? Are we clear enough? Okay, so now I'll be very slow so that you understand what we're doing. Okay, so now they are saying we find the union set of A complement, the union of A complement union B complement. So let's do this. Let's first of all find this guy. So A complement is this set. A complement is this particular set. Okay, from here up to there, so that is going to be from, let me see, okay, from 0 up to, so 1 is not included, so from 0 up to 1. Okay, then union 4 is not part of that, but up to 10. So 4 is not part of A complement, but it's not part of A complement. 10 is part of the universal set. Okay. And then I will say B complement is this set. Did we write it? Okay, it's there. It's coming from 0 up to 2, union 8 to 10. 8 to 10. So now you ask yourself, they are saying we unite this. Just ask yourself. So A complement union B complement. Okay, so the smallest number that we have here is 0, because we have 0 here, we have 0 here. Okay, but check, here we have 2, here we have 1. So we know that here we're going to have a 2. We get this 2 in B complement. Why am I putting 2? Because I know that 1 is some number which is within this particular range. So I'll put it there. Okay. Union. Then here I know that here I have a 4, here I have 8, but 4 is smaller than 8 and 4 is not included, so I'm going to put my 4 there, and then 10. I know that my 8 is just within this interval, so that is going to be my A complement union B complement. Up to this stage, is it clear? Is it clear? Is it clear? Okay, we proceed. So now we find this set. They are saying this particular set here. They are saying A intersection. Okay, they are saying A intersection B minus C complement, like that. Okay. So now, if you are my student, by now you know what this means. This is A intersection. Okay, so this is just the same as B intersection C complement. Then complement like that. And then this is the same as A intersection B exposed to the complement, it is B complement. C exposed to the intersection, it becomes the union set. C complement to complement exposed to complement, it becomes the set. So now we can work out what is in the brackets. Okay, hope people are clear enough and people are understanding what we're doing. I'll be very slow enough. Okay, so we now brought that on our real line. Let's go on the real line. So let's do B complement union C. B complement is this guy and this guy, but where are they uniting with C? So we are going to do the same thing. I'm going to get my B complement is here up to here. In fact, let me just get B complement. I don't even need to waste time. Just get your B complement. B complement tinakambati yenze set. Yeah, it was a set which was coming from 0 up to 2, included the union 8 to 10 included. And then twashilanda T. Then send the set C. Set C ni set ile fumakwisa. Nde kumfyana chimemba so that nekwato kumfa. C is coming from 3 to 6. 3 to 6. 3 to 6. Then tusange union set ya hivi. So monen chimove nefu twachitapa. Equation yali pe simple fe sana fi. Just get the smallest number ni 0. Then uku ili 3 ini 2. So narabura 3 njibika apa ninji wati 2 is within this range. Then union. Then ninji wati apari 6 apari 8. Narabura po small number which is 6. Ninji wati 8 is within this range. Like that. Then we have been told that let's find the intersection of this particular guy with A. So we intersect this particular guy with A. So first of all, let's go on our real line. Where is B? Where is B? Where is B intersecting with C? Where is B complement union C? We found is that, but where is it intersecting with the A? Okay, so A is intersecting with the B complement at this particular point up to here. Okay, then where is set C intersecting with A? Set C is intersecting with A at this point and at this point only. And of course, this is the region that we are looking for. Even this region here is where these guys are intersecting with C. So you go this side. So it is from here was 1 was part of set A and part of B complement. So it is going to be included. And then 2 is part of set A and B complement, it will be included. Then we get here 3 was part of everything, it will be included. Then 4 was part of everything, it will be included. So we are going to have the intersection of this guy is going to be this set from 1 to 2, from 1 to 2, the union of from 3 to 4, from 3 to 4, from 3 to 4. And this makes sense. It makes sense, okay? Because if you look at set A, okay, anyway, it makes sense. Up to this particular point, is it clear? Okay. Then we do the set operation 3. Set operation 3, they are saying we find x minus a, and then they're saying union a minus b. Can someone just tell me how this guy is going to be formulated? Can someone just tell me what is x minus a? How can it also be written? This can also be written as x intersection a complement, the union of a intersection b complement. Do we still remember this? Just unmute yourself and say yes, sir.
Yes, sir.
Okay. All right. All right. So let's first of all deal with this guy here. X intersection A complement. So let's go parallel. Let me try to wrap this so that people don't get confused. I don't want to confuse people. I don't want people to get confused in any way. There are people that are still saying there is no network, sir. There is no network. There is no network. Yeah, yeah, yeah. What should we do? People should buy network in campus. Alright, so now this is what we're going to do. We are saying x intersection a complement. X intersection a complement. So x intersection a complement, where a and x complement, where x and a complement are meeting, where
Yeah,
x
that's nice work.
uh
So you just let's say going through the tutorial sheet.
uh
So I'll be doing here. So if I'll be able to answer any, we'll come and share, guys. But the fact that we need to meet.
please mute yourself.
All right, that's a nice thought.
Chiwari Abram,
Um,
mute yourself, you are talking.
so
Abram, mute yourself. Okay, so where a complement and x are meeting nyapa. Apa so. Napa. Kwambira apa so. kusasa mfukapa. This is where x and a complement are meeting. So it's a set from 0 included to 1, the union of 4, because 4 is not part of a complement, so we're going to write open circle up to 10 included. So we'll say from 0 up to 1. So this is going to be a set from 0 up to 1 is 1 included. Sorry, from 0 up to 1, yes, 1 is included. The union of, okay, is that included? 4 is not part. 4 is not part, so we'll say 4, then up to 10. Then in the so we can also find this guy here. A intersection B complement. Let me wrap my board so that people don't miss the concept. There are people who are not good when we write a lot of things at the board, so we want to make sure that we cater for those. So now we are saying A intersection B complement. Where set A and B complement are meeting, it's here and here. This guy here is not intersecting with A at any point, so it is only at this particular point and this particular point. It is this region we are talking about. So it is at 1, 2 included. So I'll say, okay, this is at 1, 2 included. Okay, then you ask yourself, you unite this set to this set. Here you have a 0, here you have a 1, there's a 1 there. Union, here you have a 2, there you have a 4. So if you unite everything, you're going to get this set from 0 up to 1. Union of No. I disagree. It won't be like, it will be up to 2 because I know that 1 is within this range. The union of 4 up to 10. That's your final answer. Okay. That's your final answer for this particular set. So that is just how you solve this particular question. It is very, very simple. Okay, very simple things to solve, and very simple things to solve. We come to, is it clear? Thumbs up. Are we understanding? Thumbs up. Uyu atinani uyu chivalo uyu Abraham. Camera already on. The camera is on. Switch off your camera. We come to these guys. Okay. We come to irrational numbers. Okay, so irrational numbers are simply numbers that cannot be written in the form A over B. I mentioned that this A over B, we call them coprimes or positive, or you can call them integers. Okay, then I mentioned that from the concept B should never be equal 0. Because if b equals 0, then the function a over b is undefined. Now look at this. The key concept of irrational numbers, you don't want a particular figure to be expressed in the form a over b and at the same time having what we call common factors. You don't want that. If you have anything like that, it means that what you're dealing with is a rational number. Okay? You should never have this and you should never have this. Should never have common factors. So, prove that root 2 is irrational. It's a very good example I like giving. You use proof by contradiction method where you say no, in fact root of 2 is actually rational. You use contradiction method. You say it is root of 2 is equal to rational number. Then if that is the case, then root of 2 is equal to a over b. Where, please follow the steps. A lot of you don't write these steps, no wonder why you get your questions wrong. Rational number. Then you say where a and b are coprimes and that b must not equal 0. Then you should be writing what I'm writing here. Don't just write things like that. No, write whatever I'm writing. Then when you do this, you can now solve. You are going to get something like a 2 here, then a over b, like that. If you cross multiply, you are going to get 2b power 2 equal to a. Okay? So here, yeah. Okay. So we should never have common factors here. We don't want to have anything that is going to be like 3 over 6 or something which is going to be like 2 over 4 or 3 over 9. We don't want. If we have something like this, trust me, we're dealing with a rational number. So after reaching here, what you do is this. B is a factor such that if you multiply it with the 2, okay, if you multiply it with 2, you are getting a to the power 2. Okay, you are getting a to the power 2. But notice that if you divide this by 2, even here by 2, you are going to have something like b power 2 is equal to a to the power 2 over 2. Now, if you divide 2 into a, you are getting a single number. A single number, which is 2. Now, this b, which is b to the power 2, this b to the power 2 does not have any decimal. It is just b to the power 2. It is a single number. But we are look, if you get you have a squared, you divide a squared by 2, you are getting a number figure which is called b to the power 2. What does this imply? This implies that because any number that is divisible by 2 is an even number, this implies that a is an even number, because if you put 2 into a, you are getting b as a single number without any decimal point. So if you do this operation, this means that a power 2 is even, then if a to the power 2 is even, then we know that an even number multiplied by an even number is going to give us an even number. Then this implies that a in its individual capacity is also even. Cool. Then if that is the concept, then a can be it means that a can equal to 2 multiplying a factor k, like that. So we're going to get 2k. Like that. So I'm going to put my 2k here. So I'll get my b power 2 equal to a power 2 over 2. Then I'm going to say b power 2 equal to what is a. I'm going to put my 2k then here. Then I'm going to get b power 2 equal to 4k power 2 over 2. Then this is going to be b power 2 equal to 2, then k power 2 over 2 over 2. Then let me test for k to the power 2. Okay, notice that if I divide 2 into b to the power 2, I'm getting k to the power 2 as a number, which means that b to the power 2 is even, as well as b is also what? Even. But we end, the contradiction ends here. Why? Because b is an even number, as well as a, we proved that a was also an even number. So what we have here is an even number and an even number. Even number divided by even number will give you an even number. Okay, it may give you an even, so it will give you 1, right? 1 as a factor, but 1 is an integer, right? And at the same time it is what it is. In fact, these has got common factors. The common factor is 1. Okay, so it is being able to be expressed in the form a over b. But that was our contradiction. We don't want it to be expressed in this particular form. Okay, we don't want it to be expressed in this particular form. Henceforth, we have proved that the root of 2 is irrational. It can't be rational. Why? Because it can never be expressed in the form a over b. If you are clear, now thumbs up. You can ask those of questions. You can ask.
Sir, I want to ask there where there is b squared is equal to 4k squared over 2. Now, how you came about on this b squared is equal to 2k squared. Again, it's divided by 2. How you came about, how the 4 was reduced to 2k squared and still divided by 2 again?
Look, this 2 is 1. 2 ni 2. 2 divided by 2 this side. This 2 is going to go. You have k to the power 2, which is here, then b over 2. You get my point? Do you get my point? The person who was from asking, can you unmute yourself? You respond. Do you get me? Have you gotten the concept now?
I'm still behind, sir. Like when we divide, like 2 into 2 is 1 and 2 into 4
okay,
is
let me
2.
ask a question. What is 2 into 4?
It's 2.
That's the 2 which is here.
Yes.
And then if
Now
you
the two which is which we are putting on the bottom again.
what is if you want to make k squared the subject of the formula, what do you do?
Introduce two.
No, you divide both sides by 2.
Okay.
This is just an equation. Come on, you have b squared equal to 4k squared over 2. You have b to the power 2 equal to 2k. How can you make k to the power 2 the subject here? You the one who is
Okay,
confused.
I understand now, sir.
Okay. Because me, I was getting worried. Chendweshe kwaka. How do you prove that this is irrational? Proof by contradiction method. So first of all, you say root of 5 minus 1 is, first of all, you say root of 5 minus 1 is rational. And if that is the concept, then root of 5 minus 1 is going to equal to a over b, where a and b are coprimes, and that b must not equal 0. Simple steps like that. And then I'll say root of 5 is going to equal to a over b plus 1. So b like that is a plus, this is going to be b. Root of 5 is going to equal that. Now this one is very simple. You don't even have to go far. Okay? When you reach here, contradict, because you know that a and b are integers. A and b are integers. If you add these two, then you divide by b, okay, you will get what is this particular form, which we don't want because rational numbers can't be expressed in that particular form. Okay, a and b are integers. Okay, they are integers, but root of 5 is not an integer. Henceforth, root of 5 is not equal a plus b over b. This one you don't even have to go any further and far. You solve it like this and you get the final answer, provided you are able to explain on the other side using word sentences. Some of you just write this, they will mark you wrong if you can't explain what you're doing. Put these explanations also. Can someone drop a question which we can do on irrational numbers? Do you have anything? Have I taught? Have we understood? Have we understood? Are we able to solve questions on irrational numbers? Is there anyone who is having a question or something? Can I end the class? I was recording it, so I'm going to send it to you. Can I end it? Any question? All right, thank you.